Hello students, I am Subhashish. We have learnt about linear polynomials, quadratic polynomials, cubic polynomials, graphs in our previous session. In this session, we will learn about relationship between zeros and coefficients of polynomials. Polynomials are used in our day-to-day life in some way or the other. Engineers will use polynomials to model curves when designing a roller coaster, while civil engineers will use to design buildings and roads. Students use polynomials in geometry and calculus. Geometric applications of polynomials are involved in finding perimeter of a shape, area of a surface, volume of a solid. Learning outcomes. After completion of this session, you will be able to understand the relationship between the zeros and coefficients of a polynomial. Apply the formulas for sum, product and sum of products of polynomial zeros. Solve problems involving the verification of the relationships. Find the zeros of a quadratic and cubic polynomials and relate them to the polynomial's coefficients. Keywords: zeros, coefficients, quadratic polynomial, cubic polynomial, sum, product. We learnt about the polynomials and zeros of polynomials. Let us recall. We know that a polynomial p of x of degree m, the graph of y is equal to p of x, intersect the x-axis at most m points. Therefore, a polynomial p of x of degree m has at most m zeros. Let us see some examples to recall the graphs and zeros of polynomials. Example: look at the below graph and find the number of zeros. Solution: by seeing the graph, we can say that the number of zeros is equal to 1. The number of zeros for the above graph is 1 as it intersects x-axis only once. Example: look at the below graph and find the number of zeros. Solution: number of solutions is equal to 2 because the graph intersects x-axis at 2 places, so the number of zeros are 2. Now we will learn the relation between zeros and coefficients of a polynomial. We have learned that the zero of a linear polynomial of the form y equal to ax plus b is minus b by a. And in earlier classes, we learned the zeros of a quadratic polynomial can be found from the factorization. We split the middle term as the sum of those two terms, where the product of those two terms is equal to the product of first and third term. The standard form of a quadratic polynomial p of x is equal to ax square plus bx plus c. Now we split into the factors, that is ax square plus bx plus c is equal to k into x minus alpha into x minus beta. Then after multiplying the factors, we get k into x square minus alpha plus beta into x plus alpha beta. Now, by comparing the coefficients of x square, x and constant terms on both sides, we get a equal to k, b equal to minus k into alpha plus beta, c equal to k into alpha beta. This implies alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Let us look an example to clearly understand about the relation between zeros and coefficients. Consider quadratic polynomial p of x is equal to x square plus 10x plus 24. By splitting the middle term, we get x square plus 6x plus 4x plus 24. After solving, we get x plus 4 into x plus 6. So, the value of p of x is equal to x square plus 10x plus 24 is 0 when x plus 4 is equal to 0 or x plus 6 is equal to 0. That is x equal to minus 4 or x equal to minus 6. So, the zeros of the given polynomial are minus 4 and minus 6. Alpha plus beta is equal to minus b by a. Now, sum of zeros is equal to minus 4 plus of minus 6 is equal to minus 10. Minus 10 by 1, which is equal to minus coefficient of x by coefficient of x square, which is equal to minus b by a. Alpha into beta is equal to c by a. The product of zeros is equal to minus 4 into minus 6, which is equal to 24. We get 24 by 1. Which is equal to constant term by coefficient of x square, which is equal to c by a. Let us see an example on relationship between zeros and coefficients of quadratic polynomial. Example: find the zeros of a quadratic polynomial x square minus 6x plus 5 and verify the relationship between zeros and coefficients of the polynomial. Solution: we have x square minus 6x plus 5. By splitting the middle term, after solving we get x minus 1 into x minus 5. The value of p of x is equal to x square minus 6x plus 5 is 0 when x minus 1 is equal to 0 or x minus 5 is equal to 0. That is x equal to 1 or x equal to 5. So, the zeros of the given polynomial are 1 and 5. Now, alpha plus beta is equal to minus b by a. So, sum of zeros is equal to 1 plus 5, that is equal to 6. We get minus 6 by 1, which is equal to minus of coefficient of x by coefficient of x square. Alpha into beta is equal to c by a. Product of zeros, which is equal to 1 into 5, is equal to 5 by 1, that is constant term by coefficient of x square. Now, let us look at the examples related to relationship of zeros and coefficient of polynomials. Example: Find the quadratic polynomial which is having sum and product of zeros as minus 5, 4 respectively. Solution. Let the quadratic polynomial be ax squared plus bx plus c. Zeros of the quadratic polynomial be alpha, beta. Given sum of the zeros is equal to alpha plus beta is equal to minus 5, which is equal to minus b by a. Product of the zeros is equal to alpha into beta, which is equal to 4, that is equal to c by a. By comparing, we get a equal to 1, b equal to 5, c equal to 4. Now, one quadratic polynomial that best fits the above condition is x square plus 5x plus 4. Now, let us check this relation between zeros and coefficients for a cubic polynomial. Let us consider p of x is equal to x cube minus 6x square plus 11x minus 6. We can check p of x is equal to 0 when x equal to 1, 2, 3. P of x is a cubic polynomial, so it can have at most 3 zeros. So, 1, 2, 3 are the 3 zeros of the cubic polynomial p of x is equal to x cube minus 6x square plus 11x minus 6. Now, sum of the zeros is equal to 1 plus 2 plus 3 is equal to 6, that is equal to minus of minus 6 by 1. Which is equal to minus of coefficient of x square by coefficient of x cube. Product of zeros is equal to 1 into 2 into 3, which is equal to 6, which is minus of minus 6 by 1, which is equal to minus of constant term by coefficient of x square. There is one more relation, which is sum of product of zeros. Sum of product of zeros is equal to 1 into 2 plus 2 into 3 plus 3 into 1, which is equal to 2 plus 6 plus 3, which is equal to 11, that is equal to coefficient of x by coefficient of x cube. Let us see the formulae that are related to zeros and coefficients of a cubic polynomial. If alpha, beta, gamma are the zeros of cubic polynomial ax cube plus bx square plus cx plus d, then where a, b, c and d are coefficients and a, b, c, d are real numbers. Sum of the roots is alpha plus beta plus gamma is equal to minus b by a. Product of the roots is alpha into beta into gamma, which is equal to minus d by a. Sum of product of zeros is alpha into beta plus beta into gamma plus gamma into alpha, which is equal to c by a. Let us see an example of cubic polynomial over the relation between coefficients and zeros of the polynomial. Example: if 4x cube minus 10x square plus 7x minus 3 by 2 is a cubic polynomial with zeros 1 by 2, 1 by 2 and 3 by 2, verify the relation between coefficients and the zeros of the cubic polynomial. Solution: given polynomial 4x cube minus 10x square plus 7x minus 3 by 2, where a equal to 4, b equal to minus 10, c equal to 7, d equal to minus 3 by 2, and alpha equal to 1 by 2, beta equal to 1 by 2 and gamma equal to 3 by 2. Now sum of the roots is equal to alpha plus beta plus gamma that is equal to minus b by a. Now substitute alpha, beta, gamma values in the formula. We get 5 by 2. Now multiply 2 by 2. We get 10 by 4. Also we can write it as minus of minus 10 by 4, which is equal to minus b by a. Hence it is verified that sum of roots is equal to minus b by a. Sum of product of zeros is equal to alpha beta plus beta gamma plus gamma alpha, that is equal to c by a. Now substitute all the values in the given formula. After solving, we get 7 by 4. Which is equal to c by a. Hence, it is verified that sum of product of roots is equal to c by a. Product of the roots is equal to alpha into beta into gamma, which is equal to minus d by a. Now substitute all the values of alpha, beta, gamma in the formula. By multiplying all the values, we get 3 by 8. Three by 8 can be written as 3 by 2 into 1 by 4. 3 by 2 can be written as minus of minus 3 by 2 into 1 by 4, which is equal to minus d by a. Hence, it is verified that product of roots is equal to minus d by a. Hence, the relation between coefficients and the zeros of the cubic polynomial is verified. Now, let us summarize the topic of polynomials which we have learnt in this session. If alpha comma beta are the zeros of the quadratic polynomial, then alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a. If alpha, beta, gamma are the zeros of the cubic polynomial, then alpha plus beta plus gamma is equal to minus b by a, alpha into beta plus beta into gamma into alpha is equal to c by a, alpha into beta into gamma is equal to minus d by a. Thanks for watching.